Hello everyone, my name is Pranav Parekh, a student of Com 340. Today I am going to present on the topic authentication. The process of verifying a user's identity is known as authentication. It is the process of matching an incoming request with a set of identifying credentials. The submitted credentials are verified to those on a file in a database containing the authorized user's data on a machine running or within an authenticated server. Every secured computer must require all the users to be authenticated at a login time. After all, if the operating system cannot be sure who the user is, it cannot know which files and other resources he or she can access. That is why authentication is an important aspect. Back in the 1960s, the computers were massive, costly, and somewhat sluggish equipment that was out of reach of the majority of the people. Single mainframes like systems were generally found at the few colleges and major corporations. Of course, when a large group has access to only one pricey computer, there is a lot of demand. That's why colleges like MIT created time sharing operating systems like the Compatible Time Sharing System CTSS to allow several users to share the resources of a single computer. So, passwords were the first method we used to authenticate to computers more than 50 years ago. But they were immediately showed the industry some problems they had needed to solve to make them more secure. In 1970s, another important movement in the authentication was in the 1970s when Bell Labs researchers Robert Morris devised a method to safeguard the Unix operating system's master password file. Passwords should not be stored in the plain text file. As we learned from the CTSS password breach, Morris utilized a cryptographic technique known as a hash function to store the passwords in such a way that the computers could still validate them without actually storing the password themselves. Now, as more digital systems relied on passwords for securities, more researchers and hackers discovered methods to exploit them. As a result, the industry is continuously seeking more secure means of authentication. One of the most serious hazards of traditional permanent password system is that if an attacker guesses, steals, or intercepts your password, they can repeat it. To address this, what if each time a person logged in the individual used a completely different password? This is known as one-time passwords (OTP). In 1984, the Security Dynamics Technologies (INC) patented the methodology for doing just that using a special hardware device and a time-based method. Now, in the 1990s, various researchers and developed strategies to distinguish people from computers in the 1990s. CAPTCHAs, which stands for Completely Automated Public Turing Test to tell computers and humans apart, are the name given to this tactics. CAPTCHAs cannot be used to authenticate individuals, although they can help to prevent some automated authentication threats. A brute force password assault simply takes an advantage of a computer's speed to try every password iteration on a login page. To prevent these attacks, each login attempt must include a CAPTCHA solution. By restricting passwords, retires to human levels of speed, decrease the efficiency of the brute force attack. Now it's time for MFA, which is always developing but took off in 2000s. The industry divides the factor into three categories: what you know, have, or are. Something you know may be your favorite color, a password, a PIN, or a one-time password, for example. Special hardware, a digital certificate, a smart card, or a device having a digital certificate are examples of items you have. Your face, iris, fingerprints, or heartbeats are the examples of something you are. In a nutshell, by the 2000s, most other general people had adopted 2FA. Meanwhile, large organizations with high security requirements were attempting to integrate MFA authentication into additional critical information services. Now, what's the current scenario? So, in the late 2010s and 2020s should be the era of MFA for everyone due to the major decrease in the complexity and cost. Smartphones have been the key of MFA adoption among the consumers. So now we are going to talk about the serious security implications, which is an example taken from the book. In the figure A is a successful login. Figure B shows a failed attempt by the cracker into the system. Figure C shows a failed attempt to cracker login into system B. In figure B, the system completes as soon as it sees an invalid login name. This can be an issue as now the cracker knows the login name credentials are entered incorrectly, so they can try new login names until they find a valid one. In this types of flaws, we implement CAPTCHA as we talked about it in the previous slides. Now in the figure C, the cracker is always asked for a password and gets no feedback if the login name itself is valid or not. It just simply says the combination is incorrect. Now there can be one more major security issue, which is using BIOS to crack the password. The cracker can use an external operating system from USB flash drive and can mount the hard disk, thus seeking the files and folders. The best way to prevent this is to use authentication on the BIOS system. We can put some passwords on the BIOS system so that before accessing the BIOS, the user needs to enter the password. So early issues with the Unix password security. Some older operating systems maintain the password file on the disk, which is an unencrypted state, but it is secured by the standard system protection methods. Having all of the passwords on an unencrypted disk file is asking for disaster since all too frequently numerous individuals have access to it. The etc/passwd file in the Unix is used to keep track of every user on the system. Each user's username, actual name, identifying information, and basic account information are stored in the etc password file. A database record is contained on the line of the file. The record files are separated by the colon. We can use the cat command to display our system's etc password file. The image on the slide contains the first three accounts, namely root, daemon, and ucup are the system accounts, while the Rachel and Erlin are account for individual usernames. Now, what if the hacker also gets access to our encrypted files? A simple shell script used by a cracker could identify the passwords. After addressing the problems, Morris and Thompson created the Unix salt system. The Unix salt system is to associate an n-bit random numbers called salt with each password. When the password is updated, the random number is altered. The random number is saved in the password file in the encrypted form, allowing anyone to see it. Rather than simply keeping the encrypted password into the password file, the password and the random number should be concatenated and encrypted together. The encrypted outcome is then saved into the password file. Now, there's an example here taken from the book. There are five users, namely Bobby, Tony, Laura, Mark, and Deborah. Each user has one line in the file, with three entries separated by columns, login name, salt, and encrypted passwords plus salt. The notation edog4238 represents the result of the concatenating Bobby's password dog with a randomly assigned salt 4238 and running it through the encryption function E. It is the result of the encryption that it stored at the third field of the Bobby's entries. So this was the method used Unix salt to encrypt with a random number. Thank you.